Remember, you can approximate limits by plugging in values that are close to the limit. So the limit as x approaches infinity. So if you were to plug in a billion, what would happen to the y values? What would this expression equal if you plugged in a billion? Okay, and it's going to be really hard to type that in your calculator. So look, when you plug in a billion to the fourth power is so much bigger than a billion to the third power, right? And it's much, much bigger than a billion to the second power. So the point is the end behavior of this function is dictated by the highest power. So if you were to plug in a number to evaluate the limit as x approaches infinity, this term is the one that's going to be the most important. And so if you plug in a billion to the fourth power and then multiply it by -6, you're going to subtract, so you go further back in the negatives, further back in the negatives, further back in the negatives, further back in the negatives. Even if some of these were plus, like this, it wouldn't matter because this number, as you approach infinity, is going to be so much bigger than all these other numbers it won't matter. So if the leading coefficient is negative, this limit is going to be negative infinity. The y values go way down, negative. So for this one, we're thinking about plugging in positive a billion, and a billion squared is going to be really big. Then times another 5, it's going to be even bigger. And subtracted by 5 billion, well, if you square a billion, it's much, much bigger than just 5 billion. So there's no chance that we're going to turn from the positives into the negatives because of this term, because this term will always be bigger as x approaches infinity. So in other words, the highest power, if it's a positive coefficient, then you're going towards positive infinity in these questions.